Hello, students. This is a brief summary video in which we will highlight the properties of gases. So if we were to compile a list of properties, you should easily be able to come up with 4 or 5 of your own and further explain and come up with examples that illustrate this. So we know what makes a gas a gas. If the particle attraction cannot show itself and limit shape and volume because of the very high kinetic energy. And when we say very high kinetic energy, something that illustrates this is the average speed. So it depends on the condition and the specific gas, but in general, gas particles are known to travel over 2,000 miles per hour. Oh, very high kinetic energy. And so because of that kinetic energy, we know that gases expand to fill their entire container. That gives them their volume, but they take on the shape and then that entire volume of their container. We know that the particles are separated by an average of 10 diameters between one gas particle and another. And so gas particles have a lot of empty space. Remember, emptiness, nothing is a vacuum. That then delivers the very low density. In fact, we shared that if you have 1 milliliter of substance as a liquid, so for example, 1 milliliter of liquid water, that would be 5 drops in your hand from a pipette. Well, when that becomes a vapor, that 1 milliliter of liquid becomes 1,000 milliliters as gas. So what accounts for the difference? The amount of empty space because of the kinetic energy. And those particles are just naturally going to expand to fill their entire container. That's what delivers their very low density. So they have a very low mass per, but we usually report the volume in liters. So gram per liter will be the common density unit, where with liquids, we usually reference them as their mass per milliliter or centimeter cubed. Gases diffuse. Diffusion is the spontaneous, and that means it happens naturally without human beings doing anything. We don't start it, we don't allow for it, it just happens. So the spontaneous mixing of 2 fluids. All right, are gases fluid? Yes. To be a fluid, that just means the particles exchange places. And of course, within a gas, we know that that is happening. This gas particle moving in a straight line until it encounters an obstacle or another gas particle and then bouncing here, 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 here. So they're definitely exchanging places. Well, the spontaneous mixing of 2 fluids due to the rapid random motion. And so usually examples of diffusion come in, let's say that one chemistry student has an excess amount of cologne. Well, the cologne, you spray it as liquid or dab it on as liquid, but it uses the heat of our bodies to vaporize. We're the source, so it's most concentrated around us, but then it's moving at this speed. So of course, this is venturing this way, this way, this way, while other gas particles are moving. So the spontaneous mixing. And so of course, this is leading to dilution. So it's most concentrated at the source, but then gets diluted and then less concentrated as we move away from the source. Effusion is the passage of a gas out a small opening or a small hole or a narrow passage in the container. Small hole or opening in the container. All right, So if we would have a rigid container that was filled with, let's say, iodine vapor. Iodine is a solid at room temperature and pressure, but it sublimes. It transitions from solid to gas, skipping over the liquid state. So if we had this filled with iodine, well, what's also special about iodine is it's a purple vapor. And if we put a very small hole, because of the movement of gas particles, this moving here, 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 oh, it finds the hole and leaves. Here, 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 it finds the hole and leaves. Solids do not effuse because the particle attraction holds the particles in place. They would not leave the container. And a liquid would just flow until the liquid level was below the hole. Only gases really effuse because of their motion all over the container and their kinetic energy until the pressure of the gas inside equals the pressure on the outside, or the likelihood for one of the iodine on the inside to find the hole and on the outside to find the hole. So when the rate moving out is equal to the rate moving inward, or the amount or pressure of the gas on the inside equals the pressure on the outside. Well, we can use a fusion to learn a lot about our gases, but also for industrial purposes. So, imagine if we needed to deflate the gas out of a tire, or to pass a certain gas through a machine to accomplish a chemical reaction or work. Or what if we actually want to measure the speed of a gas? Well, we can control the exiting, measure flow rate, and so on to be able to measure a lot of different things about gases. So the fusion really comes in handy industrially and also lab-wise. We can pour gases because they flow. Because so many are odorless, colorless, tasteless, we really take this for granted. But of course, you can pour gases, which we'll do a lot in lab. We can compress a gas that, of course, is decreasing the volume because you're just removing this empty space. And of course, gases exert pressure. Pressure is force per unit area. And because of the collisions of gas particles with themselves and the walls of the container, it leads to a force that then is per unit area that delivers gas pressure. We are going to talk more about gas pressure in the next video.